There's no better way to understand how a star works than to look at one up close. And there's no better star to examine than our very own sun, the star that nurtures and supports life on Earth. Three satellites orbiting the sun not far from Earth took these images. They show the sun's outermost atmosphere called the corona. Its outer layers escape in a continuous solar wind. See those trails in orbit around the Earth? They show the paths of satellites. Some of them watch the sun. Others observe the weather or broadcast TV and GPS signals. These solar close-ups reveal a star that is more than just a big ball of gas. These glowing loops are solar storms. Beneath them, darker, cooler areas form, called sunspots. The sun generates the energy we feel when we step out of the shade on a sunny day. But how is this energy produced? Let's take a look. This flow, just below the sun's surface, is similar to the churning of water just before it boils. Go deeper, and we can see the swirling currents of gas that carry the sun's energy outward. This energy is generated deep in the center of the sun by one of the most powerful processes in the universe. Here, hydrogen atoms smash together, forming helium and releasing huge amounts of energy. This is called fusion, and it's why a star shines. The balance between the outward push of gas heated by fusion and the inward pull of gravity is what makes a star a star. But the sun, like many stars, makes more than light. The churning flow also generates vast magnetic fields shown by these swirling lines. Sunspots form when magnetic field lines get bunched together. Some sunspots are larger than Earth. The dynamic wind that blows away from the sun drags the magnetic field along with it at 1,000,000 miles an hour. You heard me, 1,000,000 miles an hour. Magnetic explosions on the sun can both drive strong blasts of this solar wind and produce dangerous radiation. Blasts from solar wind can interrupt TV signals and even cause blackouts. Fortunately, Earth's own magnetic field almost always protects us. Only a trickle of wind typically gets through, sliding down to the North and South poles. This causes radiant displays of light called auroras. We often think of space as empty, but the sun's influence reaches all the way out here and beyond. Saturn, another planet that has a magnetic field. Saturn has its own auroras. That line extending from Earth represents the path of Voyager 1, launched in 1977. In 2004, it discovered where the solar wind ends. Those are the greetings in 55 languages carried by Voyager on its journey to the stars. Just in case anyone's out there.
Hello from the children of planet Earth.
Voyager continues to travel across the region where the solar wind slams into the surrounding interstellar gas and the Milky Way's own magnetic field. The sun's power extends even beyond the solar system. But the sun won't always shine. What happens to most stars at the ends of their lives? $5 billion years from now, while the Milky Way is merging with its neighboring galaxy Andromeda, the sun will become what is known as a red giant. Nearly all stars do that at the ends of their lives. Its outer layers will swell towards the Earth. Now don't worry, this will happen long after humans have moved on or evolved in ways we can only imagine. The sun's interior will also change. Incredibly, that bright yellow center will be larger than the sun is today. Finally, the sun, like most stars, will blow its ashes out into the galaxy, seeding new stars, new planets, and potentially new life. The remains of the sun's core, called a white dwarf, will take billions of years to cool and fade away.